Hi all, in Year 10 5.3 for Properties of Geometrical Figures, today we are looking at deductive reasoning using quadrilaterals. So we already know many geometrical facts concerning quadrilaterals, and we know stuff about angles, parallel lines and triangles. So today we're going to just focus on quadrilaterals, and we're going to use what we've learnt so far in finding out the size of angles in quadrilaterals. So we should know from stage 4 that the angle sum of a quadrilateral, in any quadrilateral, the angles add to 360 degrees. So if we were to look at this example here, if we were to add up all of our sides, so add up our 120 degrees plus our 90 degrees plus our 80 degrees plus our 70 degrees, we would get 360 degrees. So therefore, it is a quadrilateral. So we have a quadrilateral in this shape. So we're going to use this property and the properties that we've already learnt to solve some examples. So in example 1, we have that ABDC is a parallelogram, and we want to find the size of angle X. So angle X is in here. We need to look at what we already know. So we already know that angle DEF equals 105 degrees. So I'm just going to write that over to the side here. Angle EDF equals 105 degrees because that's something that we already know. We're going to use this angle to find other things. What we have learnt in our first bit about angles and parallel lines was that we have vertically opposite angles. So that's where we look for an X shape to get our vertically opposite. And if you were to look here and draw along our lines CD and DB, you would see that we've created an X shape in so that we can find angle BDC. So to find angle BDC, it is going to be equal to angle EDF. So angle BDC equals angle EDF, where angle BDC is going to equal 105 degrees. And our reason for that is vertically opposite angles. So that means we have 105 degrees in angle BDC. Now that we know that, we can look just inside our parallelogram and try and find out what X equals. The key word about parallelogram is that these lines are parallel to one another. And we have that these lines here are parallel to one another. So we can use what we know about this in order to solve stuff to do in order to find out X. Okay, so if we look at our angle BDC, we can see that we can use our parallel lines and a transversal in order to find one of the other angles in order to find out what angle BAC is, which is what X is and what we're trying to find. So if we go around angle ACD, we will see that using our parallel lines, we have created a C shape when we turn our diagram around. When we make a C shape, that means that we have co-interior angles. So what we're going to do is we're going to try and find this angle here, angle ACD. So angle ACD is going to equal, using our co-interior properties of parallel lines, 180 degrees minus angle BDC, where angle BDC equals 105 degrees. So when we go 180 minus 105 degrees, apologies, we have 180 minus 105, which equals 75 degrees. So that means that angle ACD is equal to 75 degrees. and that is because of co-interior angles, and we have parallel lines. So we use the AC is parallel to BD. Now we can use what we have to find X. So now if we were to look at our sides, our angle BAC, which is what we're trying to find, and ACD, we can see that we've also now created another C. So what we are going to do is we are going to write that angle BAC will equal 180 degrees minus angle ACD. And we have the angle ACD is 75 degrees. So when we go 180 minus 75 degrees, this is where angle BAC equals X. We have that X equals 180 minus 75 degrees, which equals 105 degrees. And our reason is co-interior angles of parallel lines, and in this case our parallel lines are AB and CD, and that is that one solved. Now what we're going to do is we're going to just have a quick look at our next example. I'm just going to give us some more space so that we can do some working out. So in example 2, we have AF equals BF, which we have symbolized on our diagram using this. And because they are equal, it means that they're isosceles. It means it's an isosceles triangle. And then we have that we want to find the size of X. Now we don't know what X is at the moment, but we're going to use what we know in order to find it. So what we have is that we have an isosceles triangle where X is in, and then we have a couple of angles here. What you can notice if we go around this shape, B, C, C, D, D, E, is that we have 1, 2, 3, 4, 5 sides. And now that's not a quadrilateral, so we can't use that shape there to find this angle in here in order to find X using adjacent supplementary angles. So that's not the way we're going to go. What we're going to have to do is that we're going to have to use our shape ACDEF, which is a four-sided shape, in order to find this angle in here, angle CAE or BAF. It doesn't matter what you call it. So that's what we're going to have to find first. So in order to find angle CAE, is that we're going to go that it's a quadrilateral, so 360 degrees, minus 70, minus 132, and minus 110 in order to find our unknown angle. So angle CAE is going to equal 48 degrees. And how we found this, or our reason, was angle sum of a quadrilateral, and we just write angle sum of a quad for our reasoning. So now we know, using this, that our angle in here, our angle CAE, is 48 degrees. And because we have, from our figuring out that AF is equal to BF, it's an isosceles triangle, that means that we can just write, therefore, X equals 48 degrees, because the base angles of our isosceles triangles are equal. So our reasoning is base angles of isos triangle, and because there's different shapes in here, we have to state that it's triangle ABF. There we have it. We have found the size of X. Moving on to example 3, we have that ABCD is a rectangle, and we want to find the value of X, giving reasons. So what we have with this one is that we need to prove a certain couple of things about our triangles before we can solve this. So what we need to do is we need to use our properties of our shapes that we learnt in Year 7. And one property of our shapes is that when diagonals bisect each other, we have that they are equal to each other. So our diagonals AC and DB bisect each other here at E in the middle. And that means that when they bisect each other, that our side BE and EC are going to equal one another, making this an isosceles triangle. So we would write that EB equals EC, and our reasoning for that would be diagonals of a rectangle bisect each other and are equal. So that's just saying that those two sides are equal, and we have shown that using our black markings. So therefore, because we have now an isosceles triangle, we're going to write, therefore, triangle BEC is an isosceles triangle. Therefore, x equals the same base angle. That means x is going to equal our 70 degrees, and our reasoning will be base angles of isosceles triangle BEC. That is all for the theory notes for exercise 301C. If you are in my Year 10 class, you would now do questions 1 to 4 on page 60.